Trigonometric ratios of all angles are available on the calculator at the press of a button. However, it is useful to know the ratios of some special angles and use them without rushing to a calculator. And they can easily be derived. If you don't know how to derive them, then you have come to the right place. So let's just jump into the video straight away. Hey guys, this is Vikas Sharma welcoming you on behalf of Exponent to Success to yet another video of ours. Exponent to Success is an initiative that helps to add an exponent to your learning curve. If you're new here or if you're landing on our channel pages for the first time today, I would strongly recommend that you subscribe to our channel right now so that you do not miss out on any future content from us. And do not forget to click on the bell notification also so that whenever any new content is uploaded, it comes right into your inbox. Before we start with the derivation of the trigonometric ratios of some special angles, let's just revisit the properties of similar triangles. I have done a video on similar triangles in the past, and if you happen to miss that video, just click on the top right corner of the screen and you'll be taken to the video straight away. So here I have two similar triangles with me, and I call them similar because they are both right angles, and we know that this angle here is 30 degrees and this angle here is also 30 degrees. Let us call these sides, since they are right angles, let us give the traditional name to the sides A, B and C, where C is always the hypotenuse and A and B are the two legs. But since there are two of them, let me call them A1, B1 and C1. And of the other triangle, I'll call them A2, B2 and C2. So if you remember similar triangles, we know that the sides of similar triangles, of any two similar triangles, always are in the same proportion. First of all, let's see whether these triangles are similar or not. So both are right angle triangles, both have one angle of 30 degrees. So it's obvious that the third angle is also going to be 60 degrees in both the triangles. And if that is the case, if all three angles are equal, or if we can just say that any two angles are equal, then the triangles have to be similar to each other. And if they are similar, according to the properties of similar triangles, any pair of corresponding side in each triangle is going to be in the same ratio of any other corresponding side in each triangle. So from these two triangles, we can say that A1 over A2 is going to be the same as B1 over B2, which will be the same as C1 over C2. Since A1 and A2 are corresponding sides in both the triangles, so are B1 and B2, and so are C1 and C2, where C1 and C2 are hypotenuses of the respective triangles. Now this should not be C over 2, it should be C2. So let me make that correction. Now let us have a look at these two ratios, which says that A1 over A2 is the same as B1 over B2. Now if I take just the denominator of this side to the numerator there and bring the numerator to the denominator here, it is not going to make any difference to the equation. Or I can say I just divide both sides by B1. So what we get instead is that A1 over A2 times B1 is the same as 1 over B2, since B1 is going to cancel out. And then multiplying both sides by A2, I get A2 will get cancelled out here. So I get that A1 over B1 is equal to A2 over B2, which means that even if I take the proportions, now let us look at the sides. A1 is here, B1 is here, A2 is here and B2 is here, which means I do not have to look at the corresponding sides in each triangle. Even if I take the proportion of any two sides in one triangle, then obviously they are going to be in proportion in the other triangle as well. Now let's come to the trigonometry part of it. Now we learned in the last video that for any particular angle, the ratios of the sides are always going to be in proportion, and they will always be in the same ratio for every triangle of that angle that you make. So every right triangle with a 30-degree angle will have the same ratio of A1 over B1 in all the triangles, no matter what size the triangle is. So let's just find out what the ratios are. Now here what I have with me is an equilateral triangle. But before that, let me mark the angles here. Since it's an equilateral triangle, therefore we know that this side is equal to this side and this side is equal to this side. So let's call each of these sides as x. And we also know that each angle in this triangle is going to be 60 degrees. So these two are 60 degrees, and so will this angle be 60 degrees. Now let me drop a perpendicular from the top vertex to the base. So if this is a perpendicular, we know that this angle is going to be 90 degrees and this angle is going to be 90 degrees. Now what we have here is we can prove that these two triangles are congruent, and there are a number of ways to prove that. Since we have got two angles which are equal in both the triangles, obviously the third angle also has to be equal, which is 30 degrees each. uh, Plus, since we've got this side is equal to this side, both are x, then therefore by ASA these two triangles are congruent. Or we can also say that we have got a right angle triangle, we have got the hypotenuse, and this side is common in both the triangles. So both these triangles are going to be congruent by the RHS condition also. Now, once we have proved that, just let us look at only one of these triangles. So let me take the triangle on the left side and let me call that ABC. One more thing that I want to tell you is that if the base was originally x, and if these two angles are not, if these two triangles are now congruent to each other, then the base of each congruent triangle will be x over 2. So what we know is that the side opposite to the 30-degree angle, if you look at that, and the side opposite to the 90-degree angle, if you look at that, the side opposite to the 90-degree angle is going to be exactly the double of the side which is opposite to the 30-degree angle. Same goes for this triangle also. Let me call this triangle ABC and let this triangle be ACD. What about the height? What will be the ratio of the height? Now, since the angles are all going to be the same, the heights have to be in the same proportion no matter what triangle you make, what size you make, it does not matter. They are always going to be in the same proportion. So since we know the hypotenuse and we know the base, we can easily find the perpendicular using the Pythagoras theorem, which says that the hypotenuse square, which is x square over here, is equal to the height. Let's call that h for the moment, will be equal to h square plus the square of the base, which is going to be x over 2 whole square. Now since we want to find the value of h square, let's subtract x over 2 whole square from both the sides. So what we get is h square will be equal to x square minus x over 2 whole square. Opening the brackets, I get x square minus x square over 4, and then we can take 4 as the common denominator, and this becomes 4x square minus x square, that should be equal to h square. Therefore h square will be equal to 3x square over 4, or and then I can take the square root of both the sides. So the square and the square root get cancelled, so we get h is equal to the square root of 3 is going to be root 3, the square root of x is going to be x, and the square root of 4 is going to be 2. So the height is going to be in the ratio of root 3 over 2 times x. Now obviously whenever we take a square root, it has to be both plus and minus, since the square of a negative number is also going to give you the same answer as the square of a positive number of the same magnitude. But in this case we cannot take the negative sign, since these we are measuring distances, so obviously they cannot be negative. Now before we go further, let's look at an isosceles triangle also. So let's say this angle is 45 degrees and so is this angle 45 degrees. So if both are 45 degrees, then obviously by the angle sum property, this angle is going to be 90 degrees, or it's a right triangle. So in this, and if these two angles are equal, then obviously this side and this side are going to be equal. So for a moment, let me call these two sides as x. And since it's already a right triangle, we do not need to drop a perpendicular to this. We know both the base as well as the perpendicular, they are both going to be x. So according to the Pythagorean theorem, if I want to calculate the c, or the hypotenuse, so c square will be equal to x square plus x square, or I can say that c square will be equal to 2 times x square. And then I just take the square root of both sides. So the square root of c square will become c, and the square root of 2x square will be equal to root of 2 cannot be simplified, so I just write it as root 2, and the root of x square will become x. So this side c is going to be nothing but root 2 times x. Now let's come to deriving the trigonometric ratios of some special angles. So what I've got here, I've got two triangles with me. One of them is a 30, 60, 90 triangle, and it's called a 30, 60, 90 triangle because the angles in this triangle are 30, 60, and 90. And the other is a isosceles triangle. So these two sides are equal, and both these angles are going to be 45 degrees, which is why this triangle is also called the 45, 45, 90 triangle. Now, since we have already calculated the ratios, we know that in triangles of these sizes of 30 and 60, in any 30, 60, 90 triangles, the ratio of the sides are always going to be in the ratio 1 is to 2 is to root 3. And in a 45, 45, 90 triangle, they are always going to be in the ratio 1 is to 1 is to root 2. Which means that in this 30, 60, 90 triangle, if I take the side opposite to the 30-degree angle, that's going to be, if I assume that to be 1 unit, since it's always easier to work with unit circle like I told you in the last video. So in the last video also we have done some basic trigonometry. We learned about the history of trigonometry, and if you have happened to miss that video, just click on the top right corner of the screen and you'll be taken to the video straight away. Meanwhile, I would also like to know what you felt about that video and how are you feeling about this video right now. So just drop into the comment section and leave your comments there. So if the side opposite to the 30-degree angle is 1, then obviously the side opposite to the 90-degree angle will be 2, since they are in the ratio 1 is to 2 is to root 3, and this obviously will be root 3. In this case, if I take both the sides, both the equal sides as 1, then obviously this is going to be root 2. Now let's just write the ratios and see what we get. So initially I'm going to take sine of theta. Let's call that theta only, since the theta is the angle that I'm assuming to be here. So that theta is going to be variable. So let me just write it as sine theta. The other ratio that we need is cos theta or cosine theta. The third is the tan theta or the tangent theta. Fourth is the reciprocal of sine, which is the cosecant theta or cosec theta. The reciprocal of cos is the sec theta or secant theta, and the reciprocal of tan is going to be cotangent theta or simply cot theta. And since the angles are going to be variable, let me take the ratios for 30 degrees, 45 degrees, and 60 degrees. So now let's just come to calculating the ratios. Before we start calculating them, we should remember this rule of SOHCAHTOA, which means sine of an angle is opposite over hypotenuse, cos of an angle is adjacent over hypotenuse, tan of an angle is opposite over adjacent. And we learned in the last video which is the opposite side, which is the adjacent side, and which is the hypotenuse. Hypotenuse is the side which is always opposite to the right angle. And if you still have some confusion about which is the opposite side and which is the adjacent side, then just refer to the previous video. The link to that video will come in the end of this video. So coming back to these triangles, 30 degrees, sine of 30 degrees. So sine is obviously opposite over hypotenuse. So the side opposite to the 30-degree angle is 1. Hypotenuse is 2. So sine of 30 is 1 over 2. Sine of 45. So if we look at the 45, 45, 90 triangle, it's again any 45-degree angle you take the side opposite to that. So the side opposite to that is 1 over the hypotenuse, which is root 2. Sine of 60, coming back to the 30, 60, 90 triangle. Now if we are taking the 60-degree angle here, then the side opposite to that is going to be root 3 over 2. Similarly, we can find the cosine of 30, 45, and 60. So cosine is going to be adjacent over hypotenuse. Look at the 30-degree angle. The adjacent side is going to be root 3. So adjacent over hypotenuse of the cosine would be root 3 over 2. For a 45-degree angle, so it's going to be adjacent, which is again 1 over root 2. And for a 60-degree angle, the side adjacent to the 60-degree angle is going to be 1 and the hypotenuse is 2. So 1 over 2. Now, while we have just calculated 30, 45 and 60, why don't we do 0 degrees and 90 degrees as well, since they are not very difficult to calculate. As I told you in the last video also, if I bring this angle here, the 30-degree angle, if I keep reducing that angle, then obviously the side opposite is going to become shorter and shorter. So if I have a triangle which is something like this, where the angle is very small, then you see how the side opposite to that small angle is going to be very short as well. And if this angle comes closer and closer to 0, then obviously this hypotenuse is going to be coinciding with the base at one point of time, which means the side opposite will be 0. So since the sine of an angle is opposite over hypotenuse, and if that angle becomes 0, then obviously this sine will be 0 over root 3, or I can just write it as 0. Now if this angle becomes 0, then obviously then this angle that is currently 60 degrees, that also will become 90 degrees, and this hypotenuse is going to be the same length as the base, and the angle or the side opposite to the 90-degree angle will be the base over the hypotenuse, or the opposite over hypotenuse. Since they are both going to be the same length, therefore sine of 90 degrees is going to be 1. And similarly, we can work out the cos of 0 degrees and 90 degrees also, and you can find out that they are 1 and 0 respectively. Now let's look at tan. Tan is opposite over adjacent, or there is a trigonometric identity also which says that tan theta is the same as sine theta over cos theta. And why do we say that is because sine theta is opposite over hypotenuse and cos theta is adjacent over hypotenuse. Now, if we are dividing a fraction by a fraction, we know that we can just take the numerator and multiply it to the reciprocal of the denominator. So it's going to be h over a. So h gets cancelled out and we are left with opposite over adjacent. So tan theta is going to be adjacent over opposite over adjacent, or we can simply say it's sine theta over cos theta. So if we take it as sine theta over cos theta, so 0 upon 1 I get as 0, since anything divided by 0 is going to be 0. So tan 0 will be 0. 1 over 2 multiplied by 2 over root 3. So divided by root 3 over 2 means I can just multiply it by the reciprocal 2 over root 3. The 2 gets cancelled out and this is going to be 1 over root 3. 1 over root 2 divided by 1 over root 2, obviously since they are both the same, tan of 45 is going to be 1. Then root 3 over 2 multiplied by 2 over 1, since I'm going to multiply it with the reciprocal, the 2's get cancelled out, so it's going to be root 3 over 1 or simply root 3, and tan of 90 is 1 over 0, and since anything divided by 0 is undefined, therefore tan of 90 degrees is going to be undefined. Cosec theta is nothing but the reciprocal of sine theta. So I'm just going to flip the numerator and the denominator. Now cosec theta would be 1 over 0. So in this case, cosec theta is going to be undefined. This is going to be 2. Tan of cosec of 45 is going to be root 2. Cosec of 60 is going to be 2 over root 3. And cosec of 90 is going to be 1 over 1 or 1. Sec theta would be nothing but the reciprocal of the cos theta, so it's 1 over cos theta. So I again flip the numerators and denominators. So sec 0 degrees is going to be 1 over 1 or simply 1. Root 3 over 2, the reciprocal of that is going to be 2 over root 3. 1 over root 2, so that's again root 2. 1 over 2, so that becomes 2, and 1 over 0, so that is undefined. And cot theta is the reciprocal of tan theta. So 1 over 0, again cot 0 would be undefined, since we cannot define 1 over 0. 0 division by 0 is undefined. 1 over root 3 would be root 3. 1 over 1 would be 1. 1 over root 3. And Well, this is already undefined, so let us take it as cos theta over sine theta. Since the reciprocal of sine theta over cos theta is cos theta over sine theta. So cos theta is 0, sine theta is 1, so obviously cot theta is going to be 1. Well, so there you have the trigonometric ratios with you. So that brings us to an end of the video. I hope you enjoyed the video thoroughly and you learned something useful out of it. In case you did, I would like to hear all about it, so just head down to the comment section below and leave in your comments for me. In case you are facing any problems with any of your questions, or in case you want me to cover any specific topic, just mention that in the comment section too, and I'll surely get back to you with a video. I would surely recommend that you hit on the like button below and share the video link with your friends so that they also learn something useful out of it. And in case you haven't subscribed to our channel as yet, this is the right time to do so. You see a subscribe button right in the center of the screen. Just click on that and you'll be subscribed to our channel straight away. And do not forget to click on the bell notification also so that any future content is delivered right into your inbox. As a part of your continued learning, you can click on these videos shown on the left side here. Please like and share the video. Take care. God bless.